Welcome to the deep dive. If you've ever had to run a high-resolution video over really long distances, I mean miles, not just a few feet, you absolutely know what a massive headache it can be. Costly, complex. So today, we're diving into the tech that solves this using one specific device as our example. The DVIgear DVI-7317 4K HDMI fiber optic extender. Our mission really is to figure out the core breakthrough. How does this box, priced around, what, $700, send a 4K signal potentially miles using just one thin strand of fiber optic cable? That seems counterintuitive. It cuts the cabling needed in half, basically.
Right, and that capability, that core magic, it really comes down to wavelength division multiplexing.
Yeah.
WDM, that's the key mechanism here.
So, yeah.
Yeah, it's what lets you get that full two-way communication over, like you said, minimal infrastructure. It's a pretty big deal for, system design, cost, and thinking ahead.
Okay, let's unpack that, because that's the central mystery for me. One strand of fiber.
Right.
How are you sending the main video signal out from the transmitter, the TX, to the receiver, the RX? And at the same time, getting essential stuff back the other way, like the EID handshake, the display info, and the HDCP copy protection keys. Those have to go from RX back to TX.
Exactly, and it works by using different colors of light, so different wavelengths.
Okay.
WDM assigns two completely separate optical channels on that single fiber. So the main video signal, the really high-speed stuff, needing about 10.3 gigabits per second. That travels downstream using the 1310 nanometer wavelength.
10.3 gigs, okay.
On 1310.
And then simultaneously, those critical return signal, the EDI, HDCP, all that they travel back upstream on a different wavelength, 1550 nanometers. That return channel is much lower bandwidth, only needs about 250 megabits per second. So they just pass each other inside the fiber optically without interfering. Wait, really? No interference. You've got two light signals in the same tiny core. Doesn't that cause, crosstalk or issues? Seems like physics would fight you there.
Well, not significantly in this setup. The key is that those wavelengths, 1310 and 1550, they're actually quite far apart in the optical spectrum, so they act almost like completely separate lanes. That separation is wide enough to keep the data clean.
Got it. Okay. And speaking of clean signals, the performance specs look pretty solid. It handles HDMI 1.4, it's HDCP compliant, obviously, and resolutions up to 4K UHD, which specifically is 3840 by 2160 at 30 frames per second with full 4.4.4 color. It's good, but it can do 4K at 60 frames per second only if you drop to 4.2.0 color subsampling. How much of a real-world hit is that compression for, professional use where image detail is critical?
That can be a significant trade-off, yeah. And it leads us right into what you could call the critical distance paradox, the maximum distance you could actually run this thing. It varies wildly depending on the type of fiber you use and, crucially, whether HDCP is active.
Ah, okay. So tell me about that.
Sure. So if you're in a scenario where you don't need HDCP, maybe some kind of closed-circuit monitoring or industrial display, something like that, the distances are impressive. With single-mode fiber, SMF, you can go over 1.2 miles. That's about 2,000 meters. Even with multi-mode fiber, MMF, you're looking at 2,600 feet on OM4, maybe 1,800 feet on OM3. Still pretty far.
Right. 1.2 miles is huge. But you said if HDCP is off, what happens when you turn it on? Because most sources, Blu-ray players, streamers, they require HDCP.
Exactly. This is the crucial part for system planning. The moment you need HDCP support, that maximum distance just plummets.
Plummets how much?
Down to 1,000 feet, about 300 meters. And that's across all fiber types. Single mode, multi-mode, doesn't matter.
Wow.
300 meters is the limit with HDCP on.
Wow. Wait, seriously. From over a mile down to 300 meters just by enabling copyright protection, even on the best single mode fiber, that's a massive limitation to know about.
It is absolutely critical. And it's not actually the fiber's fault. It's purity or bandwidth. It's the HDCP protocol itself. The handshake process for HDCP has really strict built-in timing requirements. There's a maximum latency allowed for that key exchange between the source and the display.
So
if the signal takes too long to travel the round trip, anything much over that 300 meters, the delay, the latency exceeds the protocol's tolerance, and the handshake just fails, the picture goes blank.
Got it. So the physics of the protocol, not the optics, limits the distance when security's on. That makes sense.
Precisely. But even with that HDCP limit, the fundamental advantages of fiber are still huge, especially for critical systems. You get, total immunity to electrical noise, RFI, EMI.
Yeah.
That's massive for places like hospitals, near MRI machines, or secure government facilities. The signal is just inherently cleaner and safer.
And logistics-wise, it seems pretty flexible. I saw the transmitter unit, the TX, can even be powered off a USB port with an optional cable. That's handy for field installs. Plus a 3-year warranty, which is decent.
Yeah, those practical points matter. And if you step back and look at the whole picture, the WDM tech enabling this, the source docs we looked at call it an ideal future-proof choice. Mostly because it gives you that long-reach two-way traffic over just one cable strand, saving infrastructure costs down the line.
Right. So let's connect those dots for a final thought. The spec sheet mentions it handles 8-channel LPCM audio, so that's full 7.1 surround sound, and it supports 12-bit color depth, which is, pretty deep color. Combine that high-quality audio and deep color with the long-distance fiber capability and that really low RFMA profile we talked about. What kind of specialized things does that suddenly make possible for you? You could maybe isolate a high-precision medical imaging control room, like for an MRI, potentially miles away from the actual noisy scanner room, but still get perfect 12-bit visuals and clear audio. Or think about secure command centers needing absolute signal integrity and that deep color for data analysis, far from any potential interference. That seems like the kind of niche but critical power this tech unlocks way beyond just sending a movie across a building. Makes you think, huh?